Hello, students. Oh, finally we got connected. Yeah. As I told you, today we will start the next lesson, that is sets. This lesson also carries the same marks. Again, someone has written on the board. So I will come back. I will close the board. Okay, good afternoon, Sagar. Yes, today we are here to discuss about the next lesson, that is sets. This lesson carries 8 marks in the exam. So this is also an important lesson. And so we have to learn first the synopsis for this lesson, all the important points. So let me paste a few points. On the board and let us discuss. What is a set? Set is collection of objects, but it must be well defined. Well defined means as soon as you see, you must recognize what is the pattern, what is going on. So it should be well defined collection. Then a set can be written in 2 forms, roster form, set builder form. There are different types of sets. The first one is null set or empty set. 8 marks, Lohit, for sets, 8 marks, weightage is 8. Okay. Now, null set or empty set means a set which is denoted by phi. So if I write phi, it is a null set or empty set. Or if I write like this, it is a null set or empty set. But this is not null set, because in this set, if I write phi, it is not null set, because in this set there is an element and that element is phi. So this you can't call as a set. Set means, null set means like this or like this. Then null set is subset of every set. Phi you should never write inside the brackets. Like this you should not write. The next is singleton set. If the set is having only one element, that is called singleton set. Finite set means if you can count the elements, 1, 2, 3, 4, 5 elements are there, that set is called finite set. And the number of elements in this set A is written as 5. N of A, cardinal number of the set, is 5. This is what you tell. Infinite set means you cannot count how many elements are there. 1, 2, 3, 4, many more are there. So cardinal number of this set A is infinity. We can't count and tell actually how many elements are there. So such a set is called infinite set. There are some more types of sets. I'll put it on the board. Here again, some more types. Equivalent set. If number of elements in set A and number of elements in set B are equal, only number of elements are equal. For example, in A, if you have A, B, C, and in B, you have 1, 2, 3. Here, cardinal number of set A is 3. Cardinal number of set B is 3. These two are equal. That means you can say A is equivalent to B. Set A and B are equivalent sets. But equal sets means exactly A and B should be equal. That means if A has 1, 2, 3 and B has 2, 1, 3, here set A will be equal to set. Then you can say equal. So see the difference between equivalent sets and equal sets. Equal means exactly 1, 2, 3. Elements also will be equal. Okay, next. Universal set. Universal set means it is the largest set. In universal set, all sets you will have. It is the super set. Universal set is denoted by U. Power set. Next, power set. Count the number of subsets. Count the number of subsets. That is called power set. Suppose I will give you S. I'll give you S as 1, 2, 3. Now I will make subsets. How can I make subsets? Empty set is a subset. Just one elements. 1, 2, 3. These are subsets. Then two elements. 1, 2, 2, 3, 1, 3. These are subsets. Then all the 3 elements are the subsets. So if you keep all the subsets and make a set, this set is called power set. Power set we denote by P of S. Next, if A is, what is meant by subset? If A is subset of B, then all the elements of A are present in B. See, suppose this is the subset. See, 2 is present here. See, 3 is present here. So, if you take any element of A, that means it is the element of B also. Then you will say that A is subset of B. Every set is subset of itself. A is subset of A. See here, this set is subset of this set. Same. Phi is a subset of every set. See here, phi is the subset. It is counted as subset. Okay, next formulas I'm pasting. This is the next. If A is subset of B, B is subset of C, that means A will be subset of C. For example, I'll tell you. A is 1, 2. B is 1, 2, 3. And C is 1, 2, 3, 4. You see, all the elements of A are present in B. That's why A is subset of B. Next, all the elements of B are present in C. So B is subset of C. And then what happens? You can see all the elements of A are present in C. That means A is subset of C. This is what they say. Now there is a difference between proper subset and subset. If you write subset, you will write like this. Subset means this symbol. Proper subset means just like this. What is the difference between subset and proper subset? A is proper subset of B. Write like this. If A is subset of B, we can have B as subset of A. But if A is proper subset of B, we cannot have B is proper subset of A. What does that mean? Very easy, I will tell you. In subset, equal to also can happen. Like, if A is 1, 2, 3 and B is 1, 2, 3, then I can write A is subset of B, B is subset of A. All the elements of A are there in B. All the elements of B are there in A. That means actually they are equal to. They are equal to each other. That can happen when you call subset. But in proper subset, that cannot happen. Like, suppose if I give you A is 1, 2, 3, then this is the proper subset. 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 1, 2 is the proper subset. 2, 3 is the proper subset. 3, 1 is the proper subset. But 1, 2, 3 is not the proper subset. It is just the subset because it is equal to A. It is same as A. So you can't call it as proper subset, but you can call it as subset. That is the difference between subset and proper subset. I hope you understood the difference. Then, okay, good. Sagar understood. That's good. Now, like with numbers, we do addition, subtraction, multiplication, division, and all. Like that, with sets also, we can do a few things. They are called operations, but they are not addition, subtraction. Okay, Kumar also said, yes, he understood. So remember the difference between what is proper subset, what is subset, you must remember. Okay, so in sets, we can't add, subtract, multiply, divide. Okay, Soundarya also understood. Good. We cannot add, subtract, multiply, divide in sets, but there are some operations similar to that, and that is first union of sets. Remember, for union, we will use this symbol or we will use or. Immediately, union means we will use the symbol U or we will use or. Whenever you see or, it is union. What do you mean by union? Union means you will take the elements of A, you will take the elements of B. That is union. If you draw the diagram, I will take all the circle, full A circle I will take. I will take full B circle also, but I will not take double times. See, all these in between, they are double times. They come in A circle, they come in B circle. But I will not take double times. I will take only one time. But I'm going to take all the elements of A, all the elements of B. That is union, just like addition. It is almost same as addition. The next operation is intersection. It is denoted by this symbol. U only, but upside down. U only upside down. This is the symbol for intersection, or whenever there is intersection, we will use and. And gives the meaning of intersection. Now, what is intersection? That you will understand better with the help of diagram. Let me show you the diagram. Intersection is not exactly multiplication, Sagar. Intersection means what? The common between A and B, which is present in both A and B. That is called intersection. The elements present in A as well as in B, both. That is called intersection. For example, if I give you A as 1, 2, 3 and B as 2, 3, 4, 5, then what is A union B? I will write all the elements of A and I will take all the elements of B. But already I wrote 2, 3, so I will just write 4, 5. This is A union B. But what is A intersection B? Whichever is common, 2 and 3 are present in both. So intersection will be 2, 3. That is intersection, common. Next, disjoint sets. If there is nothing common, then you call the sets A and B as disjoint. For example, suppose if I'll give you A as ABC and I'll give you B as 1, 2, 3. If you see A intersection B, nothing is common in both the sets. That's why empty set. Nothing is common. So here A and B are called disjoint sets. In diagram, how the disjoint set will be? It will be like this. A will be separate, B will be separate. They never touch or meet each other. Nothing is common. Both are completely separate. So disjoint sets look like this in the diagram. Okay. Now, difference of sets. Subtraction. We have subtraction. A minus B. A minus B means what? From A, remove B. From A, remove B. That means what? Suppose I will give you A as 1, 2, 3 and B as 2, 3, 4. So A minus B means what? Take the set A. But from this, remove the elements of set B. 2, 3, 4 you have to remove. 4, of course, you can't remove. You will remove 2, 3. left is 1. This is A minus B. Suppose if I say B minus A, take the set B. From this you remove A. Elements of A 1 to 3. 1 is not there, but 2, 3. 1, 2, 3 you can remove. So what is left? 4. This is A minus B. Yes. A minus B, correct, Rakshita. A minus B and B minus A. This is how you will write. Subtraction. Yes, you all are right. Kumar, right. So, what is meant by subtraction is correct, Soundarya. For A minus B, the elements belong to A, but the elements does not belong to B. B minus A means the elements belong to B, but the element does not belong to A. You have to remove A. It does not belong to A. So that is difference. That is subtraction of sets. Some properties I will read, but some properties I will not read, because it is really boring to sit and read all the properties. Whichever are interesting, I will read. Okay, the next page. Yes, you may ask how the diagram will look like A minus B, B minus A. So that I'm putting on the board now. See the first diagram. You are taking the A circle, but you are not taking the B, you are not touching the B circle at all. Only A. A minus B means only A. You are shading only A, you are not shading B at all. You are removing B. Similarly, B minus A means you will take the B circle, you will not shade A, you will remove A, you will shade only B. Like this also you can write. And you can see here, A minus B is different, B minus A is different. They are not same. See the diagrams. Then some more points I'm not reading. You can go through the points, and then after the class, you can go all through all the points. You can go through all the points. The next is symmetric difference of two sets. Symmetric difference, you can write A delta B. Delta means symmetric difference. And how will you find A delta B? You will take A minus B, you will take B minus A, and you will take union of, or you will take A union B. From that, you will remove A intersection B. That is also symmetric difference. I'll tell you what does that mean. Suppose A is 1, 2, 3 and B is 2, 3, 4, 5. So I have to find symmetric difference of A and B. First, I will take A minus B. From A, I will remove B. So left is 1. Then I will take B minus A. From B, I will remove A. So I will have 4, 5. So for this, I will take union. Union means first I will write 1, then I will write 4, 5. This is called A delta B. Symmetric difference of two sets. That is nothing but whatever is not common, that you are writing. Common are intersection. Common means intersection. Not common, that will be symmetric difference. That is why the second division. What is the second definition? What is A delta B? Take A union B, but don't take the common A intersection B. That is what they are saying. A union B means 1, 2, 3. Then don't write 2, 3, 4, 5. And A intersection B means common 2, 3. So from this set, you have to remove 2, 3. Common ones you have to remove. So not common ones you are taking. That is symmetric difference of two sets. Now, diagram, how will you represent? How will you draw the diagram? Set diagram. Suppose this is A and this is B. How will you write this? Two definitions, anything, two definitions. A minus B. A minus B means only A I have to shade. Then B minus A, only B I will shade. But I will not take the common ones. Common ones we are not shading. This is symmetric difference of A and B. The next is complement of a set. What is complement of a set? Complement of a set means A dash or AC or C of A or U minus A. That means you will take elements from U, but you will not take elements from A. You will remove A. That is complement. Or in short words, A dash means not A. In short words. See, you did not shade A. Left of all you have shaded. Only A you did not shade. Not A. Don't shade A. That is A complement. Okay, let's go to next. Some more formulas are there. I'm not explaining. You can take down and you can learn also by yourself. But you must know all these formulas, then you will be able to do questions very easy. Even if I tell you, just I have to read only. Nothing is there to explain. Whatever is there to explain, I will explain. Okay. Some more I'm pasting here. Distributive property. Like with numbers, you have distributive property. A into B plus C. AB plus AC. This is distributive property with numbers. But in sets also you have distributive property like this. A union B, intersection A union C. Here A intersection B, union A intersection C. That is distributive property. Then there is a law called De Morgan's law. De Morgan's law, A union B whole dash is A dash intersection B dash. Or A intersection B dash is A dash union B dash. Then this next one, A minus B, this intersection will become union A minus C. That is De Morgan's. Or A minus B union will become intersection A minus C. That is De Morgan's. Then some more properties of sets are there. You can go through. Not much to explain. Oh, again and again. Yes. Next set of problems. I mean, formulas. This one we can see. Number of elements in A union B will be number of elements in A plus number of elements in B. Similarly, we have this also. These formulas. Number of elements in A union B is number of elements in A plus number of elements in B. But if A and B are disjoint, nothing is common in them, then you can take this formula. Otherwise, there is another formula. And what is the other formula? It is given down. The other formula. Number of elements in A union B is number of elements in A plus number of elements in B. And whatever we are counting double times, that is A intersection B. The common region we will count double times. That one time you have to subtract, one time you have to keep. So this formula again I have explained. Let's go to some more form. Many more are there. Just go through all of them after the class. If you want, you can take some examples and then try to understand. As I have taken examples, you also can take your own examples. To understand better, instead of by hearting, if you take examples, you will understand better. So yes, of all these, one formula I want to tell you. Number of elements in A union B union C is number of elements in A plus number of elements in B plus number of elements in C minus the common between A and B minus common between B and C minus common between C and A and adding the common between A, B and C. I'll tell you with the help of diagram. Like this also you can try to understand. This is A, this is B, this is C. If you want to find number of elements in A union B union C all. So first I will take A. Number of elements in A. Then I will take number of elements in B. Then I will take number of elements in C. So in this process, what happened is I have taken A intersection B double times, B intersection C double times, and C intersection A double times. So I'm subtracting A intersection B, B intersection C, and C intersection A. One time I'm subtracting because I took double times. I'll keep one, I'll subtract. Now in this process, what happened? This part also got subtracted. This part, which is common to all A, B, C. This part is common to all. That got subtracted continuously. 3 times you added, 3 times it got subtracted. See, here you have added that 3 times. Here you have subtracted it 3 times. Nothing is left about this common for all 3. So that we are adding here. One time we are adding. So basically, when I want A union B union C, I will shade all one time. Here also I will shade only one time. Double times I will not shade anywhere. That is A union B union C, the shading part. So this is all I wanted to tell you on the sets. Let's do some questions. I'll put the questions on the board. You can start answering. Those who know, you can start answering. You need not wait for me. Okay. So I got many answers. Rakshita alone, Rakshita and Kumar are saying A. Let us see. If B is the set whose elements are obtained by adding 1 to each of the even numbers, then the set builder notation for B. To even numbers, if you add 1, obviously you will get odd numbers. So C is the correct answer. No one got the second one? Lohit got B as the answer. Kumar also B. Okay, correct. B is correct. Why? Rakshita also got B. A union B is equal to A. A is here. Inside B is there. So if you take circle A and circle B one time, then you can see A union B is A only. That means B has to be inside A. B has to be subset of A. Correct. Third one. Rakshita got A, Sagar got D. But both are not correct. A and B are finite sets. Number of elements in A cross B. What is A cross B? Suppose A is having 1, 2. B is having A, B, C. Then what is A cross B? And in A cross B, how many elements will be there? So that will be number of elements in A into number of elements in B. In A, 2 are there and in B, 3 are there. You will total have 6 elements. Yeah, C is the correct answer. How? 6 elements? I'll tell you. A cross B means 1 you will match with A, B, C. Then 2 you will match with A, B, C. These elements come under A cross B. Next, fourth question. Yes, everyone saying A. A is the correct. A union B union C. Write the elements of A 1 to 3. Write the elements of B. 3 is already written. 4, 5. Write the elements of C. 4, 5 is already written. C. 6. So option A. Next, fifth. Fifth, next one. Everyone, fifth one, you got D. Yes, that's the correct answer. If A is subset of B, B is subset of C, then A is subset of C. In the formula itself, I told you. Sixth one, next. No, sixth one, many are saying A. I can't say. Some are saying B, some are saying D. I can't say 0 belongs to the set. This is not 0. This is O. O belongs to set. This is a set. Set cannot belong to. Set has to be subset. You can't say belongs to. Belongs to you will use only for elements. Subset or proper subset you will use for sets. So this is wrong. Next, 0 element belongs to this set. What is happening? 0 is an element in this set, but they gave something else. So this is wrong. Next, C. O belongs to this set. Actually, both are same. C and D are same. So we will change C. We will write 0 belongs to 0. This is correct. C is correct. Again, here set cannot be belongs to. So C is the correct option. Actually, they gave C and D same. I corrected it. Okay, next. You can try. By the time I will paste some questions. If I paste many questions at a time, time will be saved. As many questions as possible. One full page I'm pasting. Afterwards, we will do also. Okay, till 16th I have pasted. Let's come to the point. 7th question. Many of you gave answers. Some are giving B, some are giving D. 7th question. D is the correct answer. B is not the correct answer. So, when you take this, first you will write A minus B. Just like distribution. Then you have A and C. A minus C. This is what you have to write. But what is given in the formula? If you write A minus B, A minus C, you have to take not union. Union will change to intersection. So which option is that? D. Seventh one, option D is correct, not B. Okay, next 8th. How many of you did 8th? A dash. First of all, you have to take X. X means natural numbers starting from 1 and ending at 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, what is A dash? First, you must know what is A. A is 1, 2, 3. A dash means take all, but don't take 1, 2, 3. Don't take 1, 2, 3. What are left? 4, 5, 6, 7, 8. A dash means not A. Yes, B is the correct option. But you told after I did. You must tell before I do. Ninth also I told you in formula, distribution. First A union B. Then A union C. In middle, intersection. Yes, Rakshita, Kumar, yes. But you told after I wrote on the board. Before I wrote, before I write, you must tell the answer. Okay, next. The set A means 2x. X is a natural number. Natural numbers means 1, 2, 3, 4, 5, like that. A means 2 into x. 2 into 1, 2 2s 4, 2 3 6, 2 4 8, 2 5 10, like that. And B is 4 into x. Yes, like this, Kumar. Yes, you told correct. Like that. Before I do, you have to tell. But I don't think that is the correct answer. Kumar, maybe your answer is not correct. Rakshita, maybe it's not correct. Maybe not C. Check it. Rajeshwari, yes, A is correct. Okay. So B means 4 into X. 4 into 1, 4 into 2, 4 into 3, 4 into 4, 4 into 5, many more. Now, when you take A union B, you will write first all A, 2, 4, 6, 8, 10, 12. Like that, you will write 14. After 14, 16, then 18, then 20, you will write. But when you write B, already 4 is written, 8 is written, 12, 16. So B, you need not write, already you have written. This is A union B. I said C is wrong because it is ending, but here it is not ending. So A is the correct answer. A and C are looking same, but C is ending, A is not ending. That's the difference. Yeah, now you understand. Next, A union B whole dash. 11th one, Lohit said B, Rakshita said A, Rajeshwari is saying B, A, B, you're showing it up. So which one will be correct? 11th one, A or B? B is the correct answer. De Morgan's law. A union B whole dash. This is De Morgan's law. What will become? It will become A dash B dash, but union will change to intersection. This is called De Morgan's law. Okay, I have already given on board up to 16th. I will give some more. Take it as homework. We will discuss tomorrow in the class. Up to 20, I will give you just to remember the numbers easily. I will see tomorrow how many of you will get correct answer. From 12 to 20. I'm not giving many. Let us see how many of you will get correct. You only will be the teacher, you will be student, you only will correct. Okay. See you tomorrow then.